Azure bindings simplify the process of connecting Azure functions to various services. They allow developers to focus on the core logic of their applications without worrying about the intricacies of service integration. Bindings can be input, output, or both, and they support a wide range of Azure services such as storage, Cosmos DB, and Service Bus. This presentation will delve into the details of implementing input and output bindings in Azure Functions, providing a comprehensive understanding of their usage and benefits. Input bindings in Azure Functions allow data to be passed into the function from an external source. This can be data from a storage account, a database, or even an HTTP request. The function can then process this data as needed. For example, an input binding can automatically retrieve a blob from Azure Blob Storage and pass it to the function as a parameter. This eliminates the need for manual data retrieval and simplifies the code. Output bindings enable Azure Functions to send data to an external service after processing. This could be writing data to a storage account, sending a message to a queue, or updating a database. Output bindings abstract the complexities of service integration, allowing developers to specify the destination and format of the output data. For instance, an output binding can automatically save processed data to an Azure table storage, reducing the amount of boilerplate code required. Bindings in Azure Functions are configured using the function.json file. This file defines the triggers, input bindings, and output bindings for the function. Each binding is specified with properties such as type, direction, and name. For example, an input binding for Azure Blob Storage would include the type blob, direction in, and the name of the parameter to pass the blob data to. The function.json file provides a clear and concise way to manage bindings, making it easier to maintain and update the function. Trigger bindings are a special type of input binding that initiate the execution of an Azure function. Common triggers include HTTP requests, timer schedules, and messages from Azure Service Bus. For example, an HTTP trigger can start a function when an HTTP request is received, while a timer trigger can execute a function at specified intervals. Trigger bindings are essential for creating event-driven applications in Azure, allowing functions to respond to various events seamlessly. Consider a scenario where an Azure function processes images uploaded to a blob storage container. An input binding can be configured to automatically pass the uploaded image to the function. The function.json file would include a binding with type blob trigger, direction in, and the path to the blob container. The function can then process the image, such as generating a thumbnail or extracting metadata, without needing to manually retrieve the blob data. Imagine an Azure function that processes user data and stores the results in a Cosmos DB database. An output binding can be configured to automatically save the processed data to Cosmos DB. The function.json file would include a binding with type Cosmos DB, direction out, and the connection details for the Cosmos DB instance. This allows the function to focus on processing the data, while the output binding handles the complexities of database integration. Azure functions can use multiple bindings simultaneously, allowing for complex workflows. For example, a function could use an HTTP trigger to receive a request, an input binding to retrieve additional data from a storage account, and an output binding to save the results to a database. This combination of bindings enables the function to perform multiple tasks efficiently, reducing the amount of code required and improving maintainability. When using bindings in Azure Functions, it's important to follow best practices to ensure optimal performance and maintainability. This includes using the appropriate binding types for the task, minimizing the amount of data passed through bindings, and handling errors gracefully. Additionally, it's important to keep the function.json file organized and well-documented, making it easier to understand and update the bindings as needed. Following these best practices can help create robust and efficient Azure functions. Security is a critical aspect of using bindings in Azure Functions. It's important to ensure that sensitive data is protected and that access to external services is properly secured. This includes using managed identities for authentication, encrypting data in transit and at rest, and following the principle of least privilege. Additionally, it's important to regularly review and update security settings to address any potential vulnerabilities. By prioritizing security, developers can create secure and reliable Azure functions. Monitoring and troubleshooting are essential for maintaining the reliability of Azure functions with bindings. Azure provides various tools for monitoring function performance, such as Application Insights and Azure Monitor. These tools can help identify issues with bindings, such as failed data transfers or performance bottlenecks. Additionally, logging can be used to capture detailed information about function execution, making it easier to diagnose and resolve issues. Regular monitoring and proactive troubleshooting can help ensure the smooth operation of Azure functions. Advanced binding scenarios in Azure Functions involve more complex use cases, such as chaining multiple functions together or integrating with custom services. For example, a function could use an output binding to send data to a queue, which triggers another function to process the data further. Custom bindings can also be created to support services not natively supported by Azure Functions. These advanced scenarios enable developers to create sophisticated workflows and integrations, extending the capabilities of Azure Functions. Let's explore a real-world case study of a company that implemented input and output bindings in their Azure Functions. The company needed to process large volumes of customer data from various sources and store the results in a centralized database. By using input bindings for data retrieval and output bindings for data storage, they were able to streamline their workflow and reduce the amount of custom code required. This case study highlights the practical benefits of using bindings in Azure Functions and demonstrates how they can be applied to solve real-world challenges. The landscape of Azure Functions and bindings is continually evolving, with new features and improvements being introduced regularly. Future trends include enhanced support for additional services, improved performance and scalability, and more advanced security features. Additionally, the integration of AI and machine learning capabilities into Azure Functions is expected to open up new possibilities for automation and data processing. Staying informed about these trends and developments can help developers leverage the latest advancements in Azure Functions and bindings. In conclusion, input and output bindings are powerful tools for simplifying the integration of Azure Functions with various services. They enable developers to focus on the core logic of their applications, reducing the amount of boilerplate code and improving maintainability. By understanding how to configure and use bindings effectively, developers can create robust and efficient Azure Functions. Key takeaways include the importance of following best practices, prioritizing security, and staying informed about future trends. With these insights, developers can harness the full potential of Azure Functions and bindings.